You have certainly heard of the so-called IMS technique. IMS is short for Insulated Metal Substrate. This involves sticking the circuit board onto an aluminum plate in the hope that the heat will be dissipated inside the metal. We will use numerical simulations to show how it works in basic terms. We assume that each of the 60 LEDs dissipates 100 milliwatts of power. The example is taken from the Cadence OrCAD tutorials. We use our own export script, and our thermal simulation software has a wizard to import. The board geometry is quickly imported and a 3D model is created. The steady-state temperature of the LED without an IMS plate is approximately 90 degrees Celsius. In a pseudo-transient animation, you see how the heat is flowing across the board and where it never gets to. The outer areas of the PCB are not heat 'em up and therefore do not contribute to cooling. Further observe that not all LEDs are at the same temperature. This is due to details of the copper pattern on the top face. Let us stick an aluminum plate to the back. We don't need a CAD model to do it. The temperature is dropping by 20 degrees Celsius. This is because the heat can expand within the aluminum plate, thus increasing the effective area available to transfer heat to the environment. The thickness of the plate and the properties of the adhesive would now be starting points for optimization.
This is our test board in OrCAD mode. We created a script for the Cadence products OrCAD and Allegro that exports the layout, drill holes, components, and netlist. Just press the button. In TRM, you'll find a selection of readers for various electronic CAD systems. Each of them builds a simulation-capable 3D model of the board. At the simplest level, we only need to add the power losses or the currents or both, depending on what you are interested in. The table has many functions in the drop-down menu, which make your work quick and convenient. Objects can also be created and modified in the graphics panel on the right-hand side. In our case, we select a room temperature of 30 degrees Celsius. Apart from that, the default settings are sufficient and we can start calculating immediately. The maximum LED temperature is 90 degrees Celsius. You will receive the results in the form of automatic images without having to do anything. Detailed post-processing is also available, of course. I will now add an IMS plate made of aluminum. For the thermal resistance of the adhesive, I select any value and we calculate again. Now the temperature is 70 degrees Celsius. At this point, optimization could be performed. Plate thickness, thermal resistance of the adhesive, possibly finning via the thermal resistance from a heatsink catalog.
This and much more can be done with our TRM software. By the way, TRM stands for Thermal Risk Management. Ask for a test installation or a test simulation.